So in this problem, you're asked to rank a series of ionic compounds according to their acid-base properties. And what you're given are two weak acids. Here they are over here. And you're given the Kas for those, so you can tell which one is stronger and which one is weaker. And then you're given two weak bases, and you're given the Kbs for that, so that you can judge which one is weaker or stronger. So the first thing to recognize is that weak acids form basic anions. And the other important thing is that the weaker the acid, the stronger base the anion. So if I look at these two acids over here, HClO will be in equilibrium with H plus and Cl minus, and what we're really saying here is that this anion will be a weak base. And then additionally, if we look at the next one, hydrocyanic acid, HCN, will be in equilibrium with H plus and Cn minus, and that also will be a weak base. Now, what one is going to be the strongest base of these two? They're both going to be like a little bit weak, right? They're both going to be weak, but one is going to be like, more basic than the other. And the rule that we have is that the weaker the acid, the stronger base the anion is. So the weakest acid of these two is the one that has the smallest Ka. So what that's saying is that Cn minus is more basic than ClO minus, because HCN is the weaker of those two acids. Okay, so let's just put this in here. So this is going to be the most basic. Okay, so we just kind of got that figured out. Okay, and then this will be less basic. Okay, so we've got the anions figured out and what's going on with the anions. Now let's see if we can figure out what's going on with the cations, because an ionic compound or a salt has both cations and anions in it. So that's when we have to look at the bases, right? So what happens with this is this: weak bases form acidic cations, and the weaker the base, the stronger acid the cation. So that's kind of interesting. So we need to look at both of these things here. So C2H5NH2, if you dissolve that in water, it'll end up in equilibrium with C2H5NH3 plus and OH minus. Here we go. And then that cation here, this guy here, is going to be a weak acid. Okay. Alright, and if I look at the other one, which is hydroxylamine, it's a little easier to write this out because this formula is simpler. HONH2, then that's going to react with water, and that'll give me HONH3 plus and OH minus. And this guy here, we'll just give ourselves a little bit of space. This one here will be a weak acid as well. So now, what one's going to be the better acid of these two cations? And how we can tell that is that the weaker the base, the stronger the acid. So when I look in my table of Kbs, I see that my second one is the weaker base. So what that's telling me is that HO NH3 plus is most acidic, and C2H5 NH3 plus is less acidic. Okay, so we're kind of getting there. We're almost there. There's only like one real thing that we need to worry about now, is we can kind of start assigning things. You'll see as we look at the table that there's one thing that we haven't addressed. What if it has something other than these anions and cations? So it says, use this data to rank the following solutions in order of increasing pH. So increasing pH, so you know, as pH increases, it becomes more basic. So we want to have the most basic last, and we want to have the most acidic first. So this guy here, this first one here, it contains the C2H5NH3 plus anion, so it's not going to be acidic, it's going to be basic. So that one's going to go down near the bottom. The one that we know that is most basic, that one's going to go near the top. Sorry, because it's acidic, right? The one that we know that is the most acidic is HONH3 plus, and that isn't part of our list. So I'm going to put this one as number 1 as being the most acidic. Okay. So then what comes next? Can we find the most basic? That was going to be number 4, and the most basic one is going to be the one that contains the Cn minus anion. So that one there is going to be number 4. And then the next most basic would be the one that contains the ClO minus anion, which will be this one here. And then finally we've got KCl. So what we have to realize is that, and we have to look at the cation. And so what base does K plus come from? Well, it comes from a strong base, KOH. That's a strong base, and strong bases make neutral cations. So the cation isn't going to affect the pH in this case. And then the anions come from acids. The chloride anion comes from the strong acid, HCl. And so again, that means that that's neutral because strong acids produce neutral cations. So even if you didn't know that, you could still assign that as number 2. So what we wanted, right, was a list in order of increasing pH, that is from most acidic to most basic. So we ranked the first one, number 1, as the most acidic because it contained the conjugate acid of a weak base. We ranked KCl as the next most acidic because it was neutral. The cation was derived from a strong base, and the anion was derived from a strong acid. The next one we ranked, NaClO, would expect that to be a little bit basic because it's an anion that is derived from the weak acid HClO. Now, how we decided that was, and so that one goes in there. And then finally, the one that we decided that was the most basic was the one that was derived from the weak acid Cn minus. So how we decided the relative order of those last two was on the basis of the Kas of the acids.